What if I told you that the most powerful military in the world looked at its own weapons stockpile and said it's not enough? Because that's exactly what happened. And right now, the United States is in the middle of one of the biggest missile production buildups in modern history. But here's the thing, having the most advanced missiles in the world means nothing if you run out of them in the middle of a fight. Stay with me, because by the end of this video, you're going to understand exactly what America is building, why it's building it, and what it tells us about the wars the Pentagon is preparing to fight. Let's get into it. The United States has spent decades being the undisputed king of precision weaponry. From the deserts of Iraq to the mountains of Afghanistan, American missiles have proven themselves again and again. But recent conflicts, particularly the war in Ukraine, have sent a wake-up call echoing through the halls of the Pentagon. The lesson? Modern warfare burns through weapons faster than anyone expected. Ukraine has gone through artillery shells, missiles, and interceptors at a rate that shocked military planners across the Western world. And America's defense arm looked at those numbers and started asking a very uncomfortable question. If we got into a serious, high-intensity conflict with a near-peer adversary, how long would our stockpiles actually last? The answer was not reassuring, and that's what's driving everything you're about to hear. To understand why the U.S. is suddenly in such a hurry to build more missiles, you need to know about one specific report. In 2023, the Center for Strategic and International Studies, or the CSIS, published a war report. It was a detailed simulation of what would happen if China launched a military invasion of Taiwan. Now, here's where it gets interesting. In most of the scenarios they ran, the United States and its allies won. Taiwan survived, and China's invasion failed. But the victory came at a brutal cost. In scenario after scenario, U.S. forces burned through their entire stockpile of long-range precision-guided missiles in just a matter of days. Think about that. The most technologically advanced military in human history, running out of its most critical weapons in less than 2 weeks of high-intensity combat. By around day 3 to 4 in many simulations, American submarines and surface ships had fired everything they had. The long-range missile supply was gone. And when that happened, American forces had to move closer to Chinese defenses, closer to the very weapons systems designed to kill them. The report was a bombshell inside Washington defense circles. It confirmed what some analysts had been warning, but it had not built the depth of inventory needed for a full-scale, great power war. And so, the buildup began. Let's start with two of the most important missiles in the American arsenal, the JASSM-ER and the LRASM. The AGM-158B JASSM-ER, which stands for Joint Air-to-Surface Standoff Missile. Extended range is America's primary long-range cruise missile for striking targets on land. It's designed to be launched from aircraft far outside the range of enemy air defenses. The pilot never has to enter the danger zone. The missile does the dangerous work on its own, flying over 500 miles to its target using a combination of GPS navigation and an infrared seeker that lets it recognize specific targets. It's stealthy and precise, and it can carry a penetrating warhead capable of punching through hardened bunkers. Now take that same basic airframe and swap out the warhead for an anti-ship seeker, and you get the AGM-158C LRASM, or the Long-Range Anti-Ship Missile. This is something special. The LRASM doesn't just fly to a coordinate and hit whatever's there. It's designed to autonomously identify and engage specific high-value enemy vessels. It can discriminate between different ship types, select the optimal aim point on the target ship, and maneuver to avoid close-in weapon systems on the way in. It's basically a cruise missile with a brain. And here's why this matters so much right now. In any conflict in the Pacific, the ability to sink enemy warships from hundreds of miles away is absolutely critical. China has been building its navy at a staggering pace. The LRASM is one of America's most important answers to that threat. So how many are they making? Before the buildup, the combined annual production of JASSM variants and LRASM was sitting around 500 missiles per year. That number is climbing dramatically. The target is 2,200 per year by 2030. That's more than a four-fold increase. Lockheed Martin has been expanding its production lines, hiring more workers, and investing in new manufacturing capacity specifically to hit that number. If you've watched any American military action over the past 40 years, you've probably seen a Tomahawk cruise missile launch. The BGM-109 Tomahawk is the U.S. Navy's primary long-range land attack weapon. It's been in service since the 1980s, and it's been continuously upgraded to remain one of the most effective cruise missiles in existence. Modern Tomahawks fly at extremely low altitudes, sometimes just dozens of feet above the ground, to stay below radar coverage. They can navigate complex terrain, pop up over hills, and drop back down, and strike targets with pinpoint accuracy at ranges exceeding 1,000 miles. They can also loiter over a target area, receiving updated targeting data in real time before committing to the strike. That's not something most people know about the Tomahawk. It can be redirected mid-flight. Here's the production story, and this is a striking one. Before the current buildup, the U.S. Navy was buying roughly 90 Tomahawks per year. For a weapon that gets fired in significant numbers every time the U.S. conducts major strikes, 90 per year is a very thin margin. The new production target, 1,000 per year, that's not a modest increase. Raytheon is expanding its facilities to make this happen. The Navy has made clear that the Tomahawk remains central to its offensive strike capability, and they need the inventory depth to match. Now let's shift from offense to air-to-air combat, because while cruise missiles get a lot of attention, air dominance still depends heavily on the missiles that fighters use to shoot down enemy aircraft. The AIM-120 AMRAAM, or the Advanced Medium Range Air-to-Air Missile, is the backbone of American and NATO air-to-air combat capability. Nearly every Western fighter jet carries it. The F-15, F-16, F/A, 18, F-22, F-35, they all rely on the AMRAAM as their primary beyond visual range weapon. What makes the AMRAAM so effective? Once it's launched, it guides itself. It uses active radar homing, meaning it has its own radar seeker in the nose. The pilot launches it and can immediately turn away or engage another target. The missile tracks down the enemy aircraft on its own. This fire and forget capability is a major tactical advantage in a multi-threat environment. The AMRAAM has also found a second life as a surface-to-air missile. The NASAMS system, or the National Advanced Surface-to-Air Missile System, uses AMRAAMs launched from the ground to protect cities and high-value assets. Ukraine has been using NASAMS, and it's been proving its worth. Before the buildup, AMRAAM production was running between 500 and 800 missiles per year. The target is now 1,900 per year. That increase is being driven by several factors simultaneously, such as the U.S. military's own stockpile needs, allied nations ordering AMRAAMs for their own systems, and the ongoing demand from conflict zones. Raytheon, which builds the AMRAAM, has been working to expand production capacity to meet this new target. It requires not just building the missiles themselves, but securing the supply chain. Here's a question for you. What do Ukraine, South Korea, Japan, Saudi Arabia, and Germany all have in common? They all operate the Patriot air defense system, and right now, every single one of them wants more interceptor missiles than they can get. The Patriot PAC-3 MSE, or the Missile Segment Enhancement, is the latest and most capable interceptor in the Patriot family, and it is a remarkable piece of engineering. Unlike older interceptors that tried to detonate near a target to damage it with shrapnel, the PAC-3 MSE uses hit-to-kill technology. It physically collides with incoming missiles and aircraft and kills by impact. To do that against a ballistic missile traveling at several times the speed of sound, it needs extraordinary agility. The PAC-3 MSE uses tiny rockets mounted around its body called attitude control motors to make rapid course corrections at the very end of its flight. This gives it the maneuverability to chase down and intercept even maneuvering targets. It can intercept tactical ballistic missiles, cruise missiles, and advanced aircraft. It's one of the most capable air defense interceptors in service anywhere in the world. The demand for these missiles is enormous. Ukraine has been burning through interceptors at a rate that shocked everyone. The wars in the Middle East have demonstrated just how important effective air defense is. Allies are expanding their Patriot batteries and need missiles to arm them. The production numbers reflect this urgency. PAC-3 MSE production was running at around 600 interceptors per year. The target is 2,000 per year, and the plan is to get there within 7 years. Lockheed Martin is making significant investments in manufacturing capacity specifically to hit that number. As we go higher in altitude and longer in range, we reach one of the most specialized and expensive systems in the American missile defense arsenal: terminal high-altitude area defense. THAAD is designed to intercept ballistic missiles in the terminal phase of their flight or when they're coming down toward their target. It operates operates at much higher altitudes than Patriot, and it's designed specifically against the ballistic missile threat. If Patriot is the last line of defense, that is the layer before it, giving defenders two chances to intercept an incoming missile. Like the PAC-3, THAAD uses hit-to-kill technology, but it's doing so at much higher speeds and altitudes. The interceptor climbs to extremely high altitudes, sometimes approaching the edge of the atmosphere, and physically destroys the incoming warhead by direct impact. THAAD batteries are deployed in some of America's most strategically sensitive locations like South Korea, Guam, and the U.S. homeland. They represent a critical layer of defense against the kind of ballistic missile threats posed by North Korea, Iran, and potentially China or Russia. Here's the production picture. THAAD interceptors were being produced at a rate of just 96 per year. The new target is 400 per year, which is more than quadrupling production. Lockheed Martin, which also builds THAAD, has to essentially rebuild its production line to hit that number. Now here's a missile that doesn't get nearly enough credit for how remarkable it is. The RIM-174 Standard ERAM, better known as the SM-6, is in many ways the Swiss Army knife of naval missiles. And I mean that as a genuine compliment. Most missiles are designed for one job. The SM-6 was designed for several. In its primary role, it's a long-range surface-to-air missile, and it can engage aircraft, cruise missiles, and certain ballistic missile threats at ranges and altitudes no previous standard missile could reach. But the SM-6 can also be used as a surface-to-surface weapon. The Navy has demonstrated launching SM-6 against surface targets, which is basically using a naval ship to shoot a missile at another naval ship. This is a significant capability, especially for ships that might not carry dedicated anti-ship missiles. And then there's the third mission. The SM-6 has been tested as a weapon against hypersonic threats. As adversaries develop hypersonic glide vehicles and cruise missiles, the ability to intercept them becomes critical. The SM-6's speed, maneuverability, and active radar seeker make it a candidate for this extraordinarily difficult mission. The production target for SM-6 is 500 units per year. Raytheon is expanding production to meet this demand, driven by Navy requirements and Allied interest. The SM-6 is already in service with several Allied navies, and that international demand adds to the pressure on production. Before we wrap up, it's worth noting that missiles are only part of the picture. The Pentagon isn't just buying more of the weapons it already has. It's investing heavily in new categories of defensive capability. Drone threats have exploded in significance. Small unmanned systems have become a major tactical challenge. Shooting them down with Patriot interceptors or AMRAAMs would be economically insane. A $50,000 drone shot down by a $3 million missile is not a sustainable equation. So the military is investing in layered counter-drone systems, from electronic warfare jammers that disrupt drone control links, to small interceptor missiles designed specifically for the drone threat, to systems that use nets or other non-kinetic means to bring them down. The military is pursuing all of these weapons simultaneously because in modern warfare, threats don't come from one direction. So let's bring this all together. America looked at the lessons from Ukraine, studied the war games about Taiwan, and came to a clear conclusion. The stockpiles weren't enough, the production lines weren't fast enough, and the industrial capacity to surge production in a crisis simply didn't exist at the scale required. The response has been significant. JASSM and LRASM production climbing to 2,200 per year. Tomahawk production targeting 1,000 per year. AMRAAM scaling to 1,900. PAC-3 MSE pushing toward 2,000. THAAD more than quadrupling to 400. SM-6 expanding to 500. These are not small numbers. These are wartime scale production targets, and reaching them requires rebuilding manufacturing capacity, securing supply chains, training workers, and making long-term investments across the entire defense industrial base. The goal is deterrence, a military with deep stockpiles of advanced weapons backed by the industrial capacity to sustain and replace them, sends a clear signal to any adversary thinking about testing American resolve. But deterrence only works if it's credible, and credibility requires capability. The missiles in this video and the factories building them are how the United States is trying to make that credibility real. This is not about wanting war. It's about making war less likely, because history teaches us that the best way to prevent a conflict is to make absolutely clear that starting one would be a catastrophic mistake. If you found this video informative, drop drop a like and subscribe. Let me know in the comments which of these systems you think is the most strategically important. I read and reply to every comment. That's all for now, and see you in the next one.